Workers continue assembly by installing the cooling tray beneath the discharge door of the roasting chamber. The cooling tray sits on a support frame which contains a motor that turns the stirring arms inside the tray. At the back of the machine, workers install the tray's cooling fan and the motor that drives it. This gauge measures the pressure of the air that mixes with the gas going into the machine's burner. Next, they install the circulation fan. It's designed to withstand high heat and move air efficiently throughout the coffee roaster. The bottom end of the stainless steel tube connects to a vacuum motor. The top end connects to the tube protruding from the feed hopper's lid. To fill the roasting chamber, the vacuum motor sucks the raw green coffee beans up into the hopper, which drops them into the chamber, where, as they roast, their papery skin, called the chaff, breaks off. The machine's cyclone connects to the circulation fan. The fan blows hot air returning from the roasting chamber into the cyclone at high velocity. The air circulates in a downward spiral past the burner at the base of the cyclone, incinerating the smoke. This also draws the chaff out of the air into a barrel. Nozzles spray water on the chaff to prevent it from catching fire, a common hazard with traditional coffee roasters. The circulation fan then forces the clean hot air up and out the top of the cyclone through this S-shaped insulated air duct back into the roasting chamber. Technicians in the factory's electrical department assemble the machine's control panel. Among other components, the circuitry runs control systems and the machine's 6 electric motors, which operate moving parts such as the bean-drawing vacuum motor, the circulation fan, the cooling tray fan, the roasting chamber paddle, and cooling tray stirring arms. Workers install the control panel in a cabinet on the side of the machine. They connect all the wires and the network cable, which enables data collection for the machine to be remotely monitored and controlled via computer or tablet. They mount the machine's computer adjacent to the control panel cabinet. Workers assemble the cooling tray system. A motor under the tray drives the stirring arms. The hot roasted coffee beans sit on top of the stainless steel screen. The cooling fan pulls ambient air through the beans, down through the openings of the screen, then out an exhaust pipe to the outdoors. The stirring arms move the beans around so that they cool quickly and evenly, which prevents them from continuing to roast. The factory runs every finished coffee roaster through multiple test roasts. After heating the roast chamber to a specific temperature, the operator uses the touch screen to release the beans into it. The hot air travels from the cyclone to the roast chamber, then through a return pipe back to the cyclone, where it's cleaned and sent back to the chamber. To know when to manually end the roast cycle, the operator views, smells, and listens to the beans, because coffee beans make cracking noises as they expand and shed their chaff. The machine can also be set to end the roast cycle automatically when the beans reach target temperature. A trap door opens to draw in ambient air. This pushes smoke in the roasting chamber to the cyclone for incineration. The computer can automatically open the roast chamber's discharge door, or the operator can do so manually. As soon as the roasted coffee beans drop into the cooling tray, the stirring arms and cooling fan automatically start up. If the beans are perfectly roasted, the machine is ready to be shipped to a coffee roasting business.